separating the guilty and the innocent, chromatography is a technique used by scientists. But how does it work? Let's find out. Chromatography is a laboratory technique for the separation of a mixture. You will need filter papers, food colors, wooden rods, a beaker, a ruler, a pencil, and some water. What you need to do, you need to cut the filter paper into a rectangle shape. I'll keep this bit here. Now I'll cut it. Draw a baseline in pencil. Please do not use ink pen as the ink will dissolve into the water. Mark 4 crosses with a pencil. Drop a very small amount of food color onto the paper. Blue, yellow, red, green. Pour some water into a beaker. Fix the paper onto a wooden rod using a paper clip. Dip the paper into the beaker, which contains a very small amount of water. Then you wait till water line rise up to reach the top. Now we are going to look at the RF value. RF value is calculated by distance traveled by the components divided by distance traveled by the solvent. So the components travel distance is A, see this much, that's the distance of the components traveled, divided by the solvent goes all the way up there, so that's the distance traveled. So that is how you calculate the RF value. Now, okay, let's look at this example. This example, the baseline is starting from 0, so baseline is here. Okay, so for substance A, it traveled is from baseline to this position here. So the reading is 0.7. And the solvent finally reached this far. So when you measure that, this part, when you measured it, it is 4.7 cm. So for compound A, it will be 0.7 divided by 4.7 gives you this value. Now for compound B, again, compound B will be, let's say, is from B baseline to there. That's the position. That's the reading. Say that's 4.1 divided by 4.7 again, give you this value. Now last one, say C. C is from baseline up to where it traveled. So it's this much reading, which is 1.8, again divided by 4.7. That gives you this value. So you can see A, B, C, they are pure substance because they only have one mark. They only got this far. But for M, you can see is a mixture of A, B, and C. Why do you know? How do you know that? Because you have, this is A, this must be A. This must be A because you see that's the distance it traveled is similar. And the B must be this one here. See, they both the same distance traveled. And C must be this one here. So M is a mixture of substance A, B, and C. Each of those have their unique RF value. Now looking at ours, our baseline is here, this pencil line. Now when you calculate, say you calculate yellow, you measure from here to here, the center is this much. You measure this point. Imagine, say this is 3 cm, and the top, the solvent, I think it went this far. So the distance will be this much. So that will be 9, let's say 9 cm. So for yellow RF will be 3 divided by 9. So that's how you can calculate the blue. Say you can calculate the blue, and you go to the center here. Go to the center, the darkest point. Maybe that's the substance traveled. Let's make it 8 cm. So the blue one will be 8 divided by 9, and the red will be from the point, central point, say here. I will measure this distance, and let's say this distance is 7. Let's say 7. So that will be RF for red will be 7 divided by 9, and so on. Then you can see this substance here is really a mixture of two colors. Can you see? So I would say them two, that's pure. Those three are pure substance, but this is a mixture of two colors. By comparing stains or inks found at a crime scene to the markers that belongs to a suspect, forensic scientists can separate the guilty and the innocent. My name is June. I am a qualified teacher of science in England, and I am a published author. My book is available on Jingdong, and it makes good gift. If you would like to support my work, please subscribe and hit the like button. I really appreciate it. Have a wonderful day, and I see you again soon.